Hi, I'm Elaine, and I'm one of Vuo's programmers. I want to explain how to use Vuo's gradient noise nodes in a composition and the various applications of gradient noise. Gradient noise is a type of noise that looks smooth and natural like this. In Vuo, you might want to use gradient noise to make a realistic texture or terrain, create a sound, or display an object that moves along a natural-looking path, which is what we will do in this tutorial. Here are the gradient noise nodes in Vuo. As you can see, there's one for 1, 2, 3, and 4 dimensions. Which one you use depends on what kind of input you're giving the node. If your input is just a real number, such as seconds, you would use the one-dimensional node. If your input is a location in a two-dimensional coordinate plane, you would use the two-dimensional node. Adding more dimensions, such as time, would change which node you use. All 4 nodes give one real number as their output, called value. You can also choose between the types of gradient noise, which are Perlin and simplex. Here's a composition that places an image in the center of the scene. Right now it's stationary, but we'll add the gradient noise nodes to make it move along a natural-looking path. First thing we'll do is add a fire periodically node. This will let us update the location of the image over time. To make it run smoothly, the interval should be low, so let's just use the typical frame rate, which is 0.04 seconds. Next, we'll add a count node. We have to make sure we're using the real count node, not the integer one. The gradient noise function has to take a real input because it is always 0 for integers. Let's add 0.01 each time we update this node. Next, we'll add a gradient noise node. And we'll add the one-dimensional one, because the input is going to be count, which is a real number, not a point. For now, let's just use Perlin noise. Eventually we want to make a point that will end up being the center of this image in the Place Image in Scene node. So let's add a Make 3D Point node. And we'll connect the value output of the gradient noise function to the x value of the 3D point. Now let's add another gradient noise node. But this time we'll do the exact same thing as we did with the other one, except connect its output to the y value of this point. Okay, it started moving, but as you can see, it's moving along a diagonal path. And that's because the x and y values here are exactly the same, because these two nodes are doing the exact same computation with the same inputs. So what we need to do is make sure this node is outputting a different value. So we need to make sure its input is different than the other one. So what we can do to solve that is put a computation between these two nodes. And what I'm going to do is subtract 1 from count before inputting it into position. And again, we have to make sure we're using the real subtract node, not the integer one. And subtract 1. Now you can see it's moving on a natural-looking path. This can be useful for simulating something like an insect flying around or a person walking, or really any other natural random movement. You might be wondering what it would look like if we use simplex noise instead of Perlin noise, so I'm going to create a new composition and compare them side by side. Let's change both of these to simplex. As you can see, it really doesn't look that different. For large amounts of data or dimensions, simplex is slightly faster, but that doesn't affect compositions like this one. Simplex noise is a little smoother too. So simplex noise is the better choice these days, but you still might want to use Perlin noise if you want the exact same sequence of numbers for which Ken Perlin won the Academy Award. Thanks for exploring Vuo's gradient noise nodes. If you'd like to learn more about Vuo development or our plans for Vuo, you can check out vuo.org. We hope you'll consider becoming a part of the Vuo community and supporting Vuo by purchasing a subscription. Thank you so much for checking out Vuo, and we look forward to seeing what you create.